Your goal after watching this video is to know what the words prime and composite mean and to apply those definitions to math. Okay, so I looked up online what prime means and what composite means. I didn't type in prime numbers or composite numbers, just the word prime and just the word composite. And here is what I found. So prime means of first importance or main. All right, the second definition that I found for prime is of the best possible quality or excellent. Think of things that are prime, okay, or of the best possible quality. So we could talk about prime rib, all right? That means it's really, really good quality meat. And when something is of the best quality, it doesn't have other things mixed in. So if you go and you order a prime rib, it's not going to have little bits of the cheap, ground up hamburger mixed in or anything like that. It's just going to be the one thing, that good quality rib meat. All right, gold. If you had gold that was of excellent quality, it wouldn't have other things mixed in. It'd be just gold. Gold that wouldn't be very valuable and wouldn't be worth much would maybe have some other minerals mixed in, some other rocks, some sand mixed in with it. The good quality gold, the prime gold, would be just one thing, just that gold. All right, so prime, excellent and of the best quality. Composite, on the other hand, means exactly the opposite according to the definitions I found. So composite means made up of various parts or elements. So there you might have some gold that's not worth a lot, that has some other rocks and minerals mixed in with it. Or you might have some meat that's not just rib meat, it's ground up with some turkey and some other parts of a cow or a pig, you just never know. All right, so that would be composite, blend of more things. The other definition says a thing made up of several parts or elements. So now we are going to apply those definitions to math and to prime numbers and composite numbers. And I would highly recommend writing this down in your math notebook. So in math, a prime number, or a number that's of best possible quality and excellence, is a number whose only factors are that number itself and 1. All right? So a prime number, just like prime gold or prime rib, we can't break it down into many different things or many different factors. All right? A prime number can only be broken down into that number itself and 1. Factors are numbers that can be multiplied to get a target number. Composite, then, when we apply it to math, a number that can be broken down into several parts, or in math we're going to say several factors. So a composite number is made up of many factors. It can be broken down into many different factors besides itself and 1. Pause this if you need more time to write it down. I'm going to move on. All right, so let's apply those definitions to a few numbers. We'll start with 50, all right? And first thing I see with 50 is 1 times 50. So 1 and 50 are both factors of 50. They're numbers that can be multiplied to get 50. So right now it looks like a prime number, right? I can multiply 1 and the number to get 50. However, if I look at it a little bit more, I can break it down into other factors. I can take 2 times 25. 2 and 25 are both factors of 50 because they're numbers that can be multiplied to get 50. Since we have several factors of 50, all right, more than just the number itself in 1, we would consider 50 a composite number. And there are some factors of 50 that I didn't even write down, like 10 and 5, for example. Let's look over here at 10. Of course, I can break down into the 10 down into the factors 1 and 10. All right, so we might think it's a prime or a composite number. Sorry, a prime number. There we go. All right, we might think it's a prime number because we can multiply 1 and the number itself. But we have to check and see if there are other factors that it can be broken down into. So I can take 2 times 5 to get 10. So now we know that 10 is not prime because it has several factors that can be multiplied to get 10. So 10 is composite. 5. There are the obvious 1 times 5 factors. All right, can I break 5 down into any other factors? 2 times 2, 3 times 2, I can't think of anything. All right, there is nothing. So 5 does not have other factors. It does not have several factors. It only has 2 factors, 1 and the number itself. So 5 is a prime number. Let's look at the number 2. All right, we'll do the obvious ones first. 1 times 2. Can I break 2 down into any other factors? Are there any other factors that can be multiplied to get 2? There aren't. There are not. So then 2 is a prime number. All right, let's continue this. A few more examples. 7. I can break down to 1 times 7. I check and see if there's anything else I can multiply. 2 times 2, 2 times 3, 3 times 4, 3 times 3. Nope, there's nothing else. So 7 is a prime number. It's made up of only 1 and the number itself. Those are its only factors. 21. 21 times 1. All right, our factors of 21. So is it prime? Let's check. Let's see if there are any other ones. If this is it, then it's prime. But I can continue trying numbers on my list. Let's try 2. 2 times anything. Is 2 times anything 21? No. All right, how about 3? 3 times 7 gives us 21. So 21 is a composite number. Remember, composite means that it's made up of several parts. Yeah? Several factors. 15. 1 times 15. 3 times 5. So we know that 15 is a composite number. It's made up of several parts, several elements, or several factors, we could say. 11. Obviously, 1 times 11. All right, so it looks prime. 2 times anything. Nope. 3 times anything. 4 times anything? Nope. So 11 has no other factors. So 11, since it just has the factors of 1 and the number itself, is also prime. All right, let's look for patterns quick. We've got even. Are even numbers all prime or all composite? Is there a pattern here? Let's check. 2, we decided earlier, is prime. We can only multiply 1 times 2 to get 2. 4 is composite. We can do 1 times 4. Or we can do 2 times 2, so it has several parts or several factors. It's composite. 6. 1 times 6, 2 times 3. 6 is also composite. 8. 2 times 4. 1 times 8. 8 is composite. 10. 1 times 10. 2 times 5. 10 is also composite. So now here's your question that you should answer on Edmodo, right? Are there any other even numbers that are prime? Or is 2 the only even number that is prime? So again, for Edmodo, you should submit this on Edmodo as proof of watching the video. Is 2 the only even number that is prime? All right, now let's look at odd numbers. 1, 3, 5, 7, 9. We'll start with those ones. Okay, 1 is a weird number. 1 is an exception. It acts like a prime number, right? We can take 1 times 1 to get 1. So the only things you can multiply to get 1 are 1 and the number itself. However, all right, 1 is technically not prime or composite. It is neither. 1 is neither a prime number nor a composite number. All right, what about 3? 1 times 3 are the only factors, so 3 is prime. What about 5? 1 times 5 are the only factors of 5, so 5 is prime. We can't break it down into many factors. Just like gold, that's prime or good quality, we can't break down into many parts. So 7, 1 times 7, that's prime. Hey, except for 1, are all odd numbers prime? What do you think? Let's try 9. 1 times 9. Prime. Wait, back up. All right, are there other numbers that we can multiply to get 9? Are there other factors of 9? 2 times, no, 2 doesn't work. 3 times, hey, 3 times 3. All right, 3 times 3 is a factor of 9, so we could do 1 times 9. We could do 3 times 3. So 9 has many factors, many parts, many elements. And remember, the definition for something that has many elements or many factors or many parts is composite. So odd numbers are a little tougher than even numbers. Some odd numbers, a lot of odd numbers are prime, but there are also a lot of odd numbers that are composite. Please remember to submit your answer to the question, is 2 the only even number that is prime? Or or are there other even numbers that are prime? Remember to answer that question on Edmodo.